Okay, so this is also a series question from the June 2018 IAL paper. So let's discuss question number 5. Express 4r plus 2 over r plus 1, r plus 2 in partial fraction. So you can see this is a proper fraction, which means the order of the numerator is lower than the order of the denominator. So we can directly go for the partial fractions. How do we go for it directly? 4r plus 2 over r plus 1, r plus 2. When you separate the partial fractions, you will give a factor for every single factor in the denominator. So a over r is the first fraction. B over r plus 1 is the second fraction. C over r plus 2 is the third fraction. Are you with me? Okay, so now let's multiply it out. We'll need to get the values of our A, B, C. So 4r plus 2 equals, multiply it out, r plus 1, r plus 2. We'll take it to the other side and multiply with the A over r, B over r plus 1 and C over r plus 2. What do I get? A into the r cancels with the r. What remains with A? R plus 1, r plus 2. I'm immediately writing it. B over r plus 1, when you multiply with r plus 1, r plus 2, r plus 1, r plus 1 cancels and you get r times r plus 2. Plus C over r plus 2, the r plus 2 cancels and you are remaining with r times r plus 1. Are you with me? Okay, so now it's time to either compare coefficients or put values for r so that you can get your values of A, B and C. So when you are inputting values, if you input values, use values for r that are advantages so that many terms will cancel out. Can I know an advantageous r value? When r is minus 2, that's correct. When r is minus 2, because when r is minus 2, I think you can see certain brackets completely cancel out. Can you see when r is minus 2? So what do you get here? 4 times minus 2. How much is 4 times minus 2? Minus 8 plus 2 equals, what happens to the first bracket when r is minus 2? Because it's minus 2, this entire term is a 0. The second bracket minus 2 is, because of minus 2 plus 2 becoming a 0, 0 times anything is 0. Second bracket also is a 0. Third bracket, you will have to get the answer. C times r is minus 2 times minus 2 plus 1. Are you with me? So minus 8 plus 2 is minus 6 equals, these two guys are 0, so we don't need them. C into minus 2 is minus 2c. Inside the bracket, what do we get? Minus 2 plus 1 is minus 1. So minus 6 equals minus 2c into minus 1 is plus 2c. So c equals minus 6 divided by 2, which is minus 3. So this is the answer for C. Are you clear with it? Okay, so when we'll go for another advantageous r value, which is what? When r is minus 1, because you can see that we have brackets with r plus 1. So if there are brackets with r plus 1, using r as minus 1 makes that entire bracket 0. So what do we get here? 4 into minus 1 is minus 4 plus 2 equals a into minus 1 plus 1 is 0, right? So which means the entire first term is a 0. The second term, does it become a 0 when r is minus 1? No, right? So we get here b into r is minus 1 into minus 1 plus 2 is, we'll write it like that for now, into minus 1 plus 2. The last part, plus c into minus 1 into minus 1 plus 1. Can you see again? Minus 1 plus 1 becomes a 0, which means this entire term is a 0. The entire term is a 0. So minus 4 plus 2 is minus 2 equals, what do we get here? 0, we don't need to consider. So b into minus 1 is minus b. Minus 1 plus 2 is a plus 1. Are you guys with me? So minus 2 equals minus b into plus 1 is minus b, which gives me what? B equals to plus 2. Do you agree? B equals to 2. Okay, so let's go for the next advantages r value. What's the next good r value we can go? When r equals, when r is 0, as you can see, because we have simply terms that just has only r. So we can go with r equals 0. So when r is 0, 4 into 0 is 0 plus 2 equals, over here what happens? The first term, does it become a 0? No, right? A into 0 plus 1, 0 plus 2. So that term is remaining. The next term, b into 0. Into 0 plus 2. Basically, multiplying by a 0. So entire term is 0. Here, c into 0. Into 0 plus 1, which means that is also 0. So I get here 2 equals a into 1 times 2, right? 0 plus 1 is 1. 0 times 2 plus 2 is 2. So 1 times 2. 2 equals 2a. 1 times 2 is 2a. So a equals 2 divided by 2 is 1. Got it? So I have the ABC values. Now what do we need to do? Input the values of ABC into this equation. Input the values of ABC into the equation. What do we get then for the partial fraction? 4r plus 2 over r plus 1, r plus 2 equals, what do we get? A over r. A over r. Can I know what was the a value? A is 1, right? So 1 over r plus b over r plus 1. So plus b is 2 over r plus 1 plus c over r plus 2. C is, so shall I put directly minus 3 directly in the front? Minus 3 over r plus 2. I just put the minus directly, or you could write plus and on top minus 3 over r plus 2. R plus 2. Is this clear, children? Is this clear? Okay, so we'll go to part B. Hence, using the method of differences, prove that the summation of 4r plus 2 over r plus 1, r plus 2 is equal to this, right? Okay, so how do we go with the method of differences? Definitely, you realize that we have to use the help of the partial fractions which we obtained in part A. Okay, let's go for the partial fractions which we got in part A. So part B, we are supposed to take the summation of 4r plus 2 over r plus 1, r plus 2. Can you all remind me the partial fractions which we got? A over r was 1 over r. B over r plus 1 was 2 over r plus 1 minus 3 over r plus 1 and 3 over r plus 2. This is what we got, right? Are you all with me? Yeah, 1 over r plus 2 over r plus 1 minus 3 over r plus 2. So instead of taking the summation of 4r plus 2 over r plus 1, r plus 2, we will now be considering the summation of 1 over r plus 2 over r plus 1 minus 3 over r plus 2. Okay, so let's take the summation. So when r equals 1, what do we get? 1 over 1 plus 2 over 1 plus 1 is 2 minus 3 over 1 plus 2 is 3. Then when r equals 2, what do we get? 1 over 2 plus 2 over 2 plus 1, that's 3 minus 3 over 2 plus 2, that's a 4. Okay, so when r equals 3, what do we get? 1 over 3 plus 2 over 3 plus 1, that's a 4, right? Minus 3 over 3 plus 2, that's 5. Now the thing is, we need to figure out the pattern which this cuts, right? So that is the most important thing. We need to figure out the pattern. Let me write a few more. R equals 4 as well, because there are 3 fractions. Now normally we'll know how to deal with 2 fractions, but over here there are 3 fractions. Okay, when r is 4, we get 1 over 4 plus 2 over 4 plus 1 is 5 minus 3 over 4 plus 2 is 6. Agreed? I will, okay, now at least at this point, it should be enough. We don't need to go for r equals 5. So we need to try to find the cutting pattern. So how does it cut? I think you can see if you try to take it 2 by 2, it doesn't work, right? If you try to take 2 by 2, it doesn't work. So we need a consistent pattern that keeps on cutting until the very end, because you have to go for the summation from where to where? From 1 to n. I had to go until n, like there's many more terms to come here. So we need a consistent cutting pattern. You know, most of the terms need to cancel out. That's what method of differences mean. Most of the terms in the middle must cancel out, leaving a few terms at the beginning and at the end. So you have to find a consistent cutting pattern that works until the very end. So why don't you try to find a cutting pattern that consists of all the 3 rows? Like for example, like maybe try diagonally. Okay, and also another important thing is your fractions should be organized. Now, do you see here the fraction denominators are in an organized manner? 1 over r, 2 over r plus 1, the denominator r plus 1, r plus 2. It's actually important when you have 3 or more fractions, when you take the method of differences, that the fractions are actually organized correctly. Otherwise, you will not be able to see the cutting pattern. Okay, so now when it's organized, try to find a diagonal pattern. So try to see diagonally. Does it work in this way diagonally? No. What about the other direction? Look at this diagonal direction. It's minus 3 over 3 plus 2 over 3 plus 1 over 3. Can you see plus 1 over 3 plus 2 over 3 is plus 3 over 3 and minus 3 over 3. It's like completely cancels out. Becomes this entire particular diagonal becomes a 0. Can you see that? So this is the consistent cutting pattern that we require. Check, does it continue downwards? Minus 3 over 4. Over here you have plus 2 over 4 plus 1 over 4. Does it add up to give you 0? So 1 over 4 plus 2 over 4, 3 over 4 and minus 3 over 4, it becomes a 0. Can you see I have a consistent cutting pattern until the end? Yes. And how many terms are remaining at the top? How many terms are remaining at the top now? There are 3 terms remaining at the top. There are 3 terms remaining at the top. Can you see? If there are 3 terms remaining at the top left corner, you should have 3 terms remaining at the bottom right corner. Okay, 3 terms at the top left means there will be 3 on the bottom right corner. So like in this similar pattern, there should be 3 remaining in the bottom right. In this manner, there's another 3 at the bottom right. Are you with me? So you don't need to try to write the middle many unnecessary terms and try to see the cutting out. We understand that there are 3 terms remaining in this corner. Okay, so in this corner means what? How do you get those corner terms? The one before the last from n minus 1 and the last one from r equals n. Okay, because this is going to come from the term before the last, n minus 1th row. Okay, let's start. So in the middle, we'll put the line. So r equals n minus 1. So 1 over n minus 1, 2 over n minus 1 plus 1 becomes n. Minus 3 over n minus 1 plus 2 is n minus 1 plus 2 is n plus 1. And r equals n. When r equals n, what do we get? 1 over n plus 2 over n plus 1 minus 3 over n plus 2. Are you with me? So now if this cutting pattern continues, you need to realize that from the bottom left, the 3 terms need to remain. Can you see? According to this pattern, these 3 needs to remain while everyone else will cancel out. So you can cancel out everyone else while these guys are remaining. Got it? Okay, now let's go for the addition. So when we go for the addition of 4r plus 2 over r plus 1, r plus 2. What do we get here? What are remaining? We have 1 plus 2 over 2 plus half, right? 1 over 1 plus 2 over 2 plus half, which is basically 1 plus 2 over 2 is also 1. 1 plus 1 plus half at the top. And at the bottom, what do we have? Minus 3 over n plus 1 plus 2 over n plus 1 minus 3 over n plus 2. Is there a particular show that they want us to show? Yeah. 2n plus 1, n plus 2. At the numerator, there's n plus b. Okay. So we have to get this, we'll have to go for the common denominator. Before we go for the common denominator, can I know the addition of 1 plus 1 plus half? 1 plus 1 is 2. 2 plus half is 5 over 2. And we can even add these 2 terms because you can see if there are like terms, it's easier to add them off and finish it. For example, minus 3 over n plus 1 and plus 2 over n plus 1 can be simplified. How can it be simplified? Because the denominator is same, we can add minus 3 plus 2 is, it's minus 1 over n plus 1. And we have minus 3 over n plus 2. So taking it like this will help us to simplify it faster. Got it? Okay, so now let's go for the common denominator. So what's the common denominator? 2 times n plus 1, n plus 2. Are you with me? 2 times n plus 1, n plus 2. So what's remaining here? The 5 multiplies with what's missing? The 2 is there. You are missing with n plus 1 and n plus 2. Here you have minus 1. You are missing out what? The n plus 1 is there. You are missing 2 and n plus 2, right? Because the n plus 1 is there over here. You're missing out the 2 and n plus 2. Then here we have minus 3. And what is the denominator? What does it lack? So n plus 2 is there. It lacks the 2 and n plus 1. So you multiply with 2 times n plus 1. This is clear? So now it's time to simplify and get the show that. You can see I have already got the denominator in that particular show that. So expand the bracket. So my numerator is going to be 5 times, expand the bracket. N into n, that's n square, n into 2, 2n plus 1n, 3n, 1 into 2 is 2. Here it's minus 1 into 2 is minus 2, right? So minus 2 into n is minus 2n, minus 2 into 2 is minus 4. The next term, minus 3 into 2, that's a 6. That's a 6. So 6 into n is minus 6 into n actually. Minus 6 into n is minus 6n, minus 6 into 1 is minus 6. Are you all with me? Expand the bracket again. We need to expand with the 5. So I get here 5n square, 5 into 3, 15n, 5 times 2 is 10. We can simplify the minus 2n minus 6n to give us minus 8n, right? Minus 4 and minus 6 can simplify to give you minus 10. Are you with me? Denominator is 2 times n plus 1 times n plus 2. And then let's simplify the numerator. So what do we get here? 5n square. What about the n terms? 15n minus 8n. How much is 15n minus 8n? Plus 7n. And you can see plus 10 minus 10 will completely cancel out. Right? So you are remaining with 2 times n plus 1 times n plus 2. So actually we are not done yet. The show that asks to take n out, right? I think the show that had n out. Yeah, there was n taken out. Can you see? So take n out and get the final part of the show then. When you take n out, it's 5n plus 7 over 2 times n plus 1 times n plus 2. This is clear? So this is the show that n times an plus b over 2n plus 1 n plus 2, and this is the show that.